no one talking? More importantly, why is no one talking about these eggs?
You see, eggs have an elliptical shape. Before that, let's think about what a conic section is. So, a conic section is the intersection of a plane and a right circular cone. An ellipse is one of the 4 types of conic sections. Before that, we have to remember the standard form of ellipses. The first is x squared divided by a squared plus y squared divided by b squared is equal to 1, or x squared divided by b squared plus y squared divided by a squared is equal to 1. Remember that an ellipse equation should always equal 1 when finding the key points or when graphing. Also, note that a will always be the biggest value. We can remember this by using the ellipses Pythagorean theorem, which is a squared equals b squared plus c squared. Adding b squared plus c squared to equal a squared makes a squared the largest. Now, remember how I mentioned key points? Well, to graph an ellipse, you must find the center, major and minor axis, vertices, covertices, and both foci. However, you won't have to find all of these, as occasionally they will be given in the problem. First, when the ellipse is not translated on the graph, and the center is 0, 0, then the vertices will be plus or minus a, 0, or 0, plus or minus a. The foci will be plus or minus c, 0, or 0 plus or minus c. Then the covertices will be plus or minus b, 0, or 0 plus or minus b, but it is not always used or asked for quite as often. Then an ellipse will always have a major and minor axis, where the major axis is equal to 2a and the minor axis is equal to 2b. The major axis, as you can see, is associated with the a value, which means the major axis will be the longest side. Then we have ellipses that are translated on the graph. These have a different center from 0, 0, and there are the equations shown. The center is h, k, and can be found on the numerator of the equation. These will be added or subtracted from the x and y, and the signs will change. For the vertices, foci, and covertices, remember to add the a value to the vertices, the b value to the covertices, and the c value to the foci. At times you will have to use the ellipses Pythagorean theorem to find a, b, or c. As you can see, the a, b, and c are sometimes added to the x value and other times to the y value. This is because of where it is placed in the equation. If a squared is in the denominator below x, then the a will be added to the x value for the vertices. The foci is on the same axis as the vertices, so in this case, it will also be added to the x value. However, the covertices is always on the opposite axis. Let's try some example problems now. Find the center, vertices, covertices, and foci of the ellipse. So the equation is x squared over 9 plus y squared over 34 is equal to 1. So first we can write the Pythagorean theorem and then plug in the values a squared and b squared into it. So c squared equals 25 and c equals 5. Then we know that a squared is 34 and a would be square root of 34. And b squared is equal to 9 while b is equal to 3. So we know that we can find the center on the numerator as h, k, but since there is nothing being added or subtracted to the x or y on the numerator, then the center is 0, 0. Then we can add a to the y value since it is under y squared to get 0, plus or minus square root of 34. Then the covertices, we can add b to the x value to get plus or minus 3, 0. For the foci, we can add c to the y value getting 0, plus or minus 5, and that's the answer. Now we must graph it. We can immediately plot the center at 0, 0, then the vertices is 0 plus or minus the square root of 34, and the square root of 34 is the equivalent to 5.8. Then we can plot the co-vertices points at plus or minus 3, 0, and the foci points at 0 plus or minus 5. Then we can connect the vertices and co-vertices to graph the ellipse shape, which is now a nice egg shape. Now on to the second example. Find the center, vertices, co-vertices, and foci of the ellipse. So the equation is x minus 4 squared all over 74 plus y minus 9 squared all over 25 equals 1. So first we can plug the numbers into the Pythagorean theorem yet again and solve for c. So c squared is equal to 49 and c will equal to 7. A squared, since it is the largest number, will be 74, and a will be the square root of 74. Then b squared will be 25, and b is equal to 5. Then we can find the center points on the numerator, which will be 4, 9, and our vertices, since the largest value a is below the x, we can add it to the x value. So the vertices will be 4 plus or minus square root of 74, 9. Then the co-vertices will be 4, 14, and 4, 4. And our foci will be 11, 9, and negative 3, 9. Then we have to graph. Now we can graph it with the key points that we just found, and the center will be the first thing I graph at 4, 9. Then the vertices at 4 plus or minus the square root of 74, 9, and adding 4 to the square root of 74, which is equivalent to 8.6, will get me 12.6, 9, and 4 minus 8.6 will be negative 4.6, 9. Then the co-vertices will be plotted at 4, 14 and 4, 4, as well as the foci at 11, 9 and negative 3, 9. Now we can try a bit of a harder example. With the major axis length of 18, the center at negative 7, 3, and foci points at 1, 3, and negative 15, 3, find and write the equation and graph it. So we have the major axis length of 18, and we know that the major axis is equal to 2a. So we can set 18 equal to 2a and find a as 9. So 9a squared or 9 squared would be 81, which is one part of our equation. Then we can find the foci points distance by adding 15 and 1 together to get 16, and dividing it by 2 to get 8. And to see if this is truly our C, then we can add and subtract 8 from negative 7, which is the center point, which we will get 1 and negative 15. So C is equal to 8, and C squared is equal to 64. So since we have a squared and c squared, we can plug this into the Pythagorean theorem and we find our answer for b squared to equal 17, which means b is equal to the square root of 17. So since we know the center, we can write x plus 7 squared is over 81 plus y minus 3 squared over 17 is equal to 1. And since we see the x value in the foci points is the value being moved, then we can assume that the vertices, which is A, is associated with the x, which is why 81 is below the x. So now we have to graph the equation. First we can graph the center point at -7, 3, and then the vertices at 2, 3, and -16, 3. Now the co-vertices is at -7, 3 plus or minus the square root of 17. And so the square root of 17 is equivalent to 4.1. And so if we add and subtract 4.1 to 3, we get 7.1 and -1.1. So -7, 7.1, and -7, -1.1. Then the foci points at 1, 3 and -15, 3. And we can connect the vertice points with the co-vertice points to get this nice ellipse shape. Now we have a word problem example. A play train set has an elliptical shaped railway measuring 26 inches long and 28 inches wide. With this information, find the ellipse equation. So we know that 36 inches long will be the major axis since it is larger than 28. And if we draw the measurements on the graph, we can see that 36 inches is on the y-axis. And so we can set 2a to 36 and get a to equal 18. So a squared would have to be 18 squared, which is 324. Then 28 inches wide will be the minor axis. So we can set it equal to 2b to get b is equal to 14 and b squared as 196. And so simply put, we can put it in the equation as x squared over 196 plus y squared over 324 is equal to 1. And in this, we can see that the center is 0 since it made no mention of the center being elsewhere.